And here's the second thing I promised. I promised to give you an extra example of the stuff that we did in class on Monday. So notice here that I've given you a specific second order differential equation with an initial condition and a derivative initial condition. So our first step in any of these differential equations, regardless if there's real roots or repeated roots or complex roots, is to write down the characteristic equation. So that's going to turn out to be r squared minus 8r plus 17 is equal to 0, where again, y double prime becomes r squared, y single prime becomes r, and then the 17 just stays as 17. Now, if this were factorable, that'd be great. However, since it's a extra example from yesterday, my guess is that we're going to have to do the quadratic formula. So over here, I'm going to say negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. I'm going to leave that to you to verify, but you should find that your roots are 4 plus or minus I. That part of it, hopefully the quadratic formula is the nicest part of all of the things that you've done. So notice here that we have alpha, in this case is 4, and beta is 1. So when I go to write my general solution, I have y, I have c1 e to the 4t cosine of t plus c2 e to the 4t and then sine of t. Because again, the 4 comes from alpha and then the 1 comes from the beta. There's the alpha and there's the beta. Since we're given initial conditions, we might as well find the first derivative here as well. So yay, here comes the product rule. So first times the derivative of the second plus second times the derivative of the first. Notice that the 4 is going to get kicked down here. Then I got to do it again. First times the derivative of the second plus second times the derivative of the first. Isn't that beautiful? Sure, we'll go with beautiful is the word we're looking for. Now notice that since our initial conditions are at 0, some of these things are going to cancel out, or we know that e to the 0 is a nice number as well. So let's deal with the initial condition here. So I know that my output is negative 4, and I'm going to input a 0. So that means I've got c1, and then e to the 0 is 1, and then cosine of 0 is 1. That's nice. And then I know that this whole entire other thing is got to go away because sine of 0 is 0. So that leaves me with c1 equaling negative 4. That's not so bad. Now if I go to the derivative, I know up there that the derivative is going to equal negative 1. So negative 1 is going to equal, in this case, then, I know that this part's going to go away because that's sine of 0. This part's going to be cosine, which is 1. And then I'm going to have 4 times c1, and c1 is negative 4. And then e to the 0, which is 1. Pardon me for all my parentheses. So that's this piece. Now I've got this piece. I have c2, e to the 4t, or e to the 40 is going to be a 1, and then cosine of 0 is 1. This last piece, since it's associated with a sine, is also going to be 0 because sine of 0 is 0. So I'm left with this lovely thing. I've got negative 1 is equal to negative 16 plus c2, which means that c2 is equal to 15. So if I put this all together, my specific solution is going to be c1, which is negative 4, so negative 4 e to the 4t cosine of t, and then c2 is 15, so plus 15 e to the 4t sine of t. There's our specific solution given our initial conditions and everything. So just to reiterate from yesterday, we tried to factor, but we weren't able to factor. So we had to use the quadratic formula, and we found our 2 complex roots. We plugged those in to find the general solution, and then we had to take the derivative to solve for the initial conditions. We plugged in, used our awesome algebra skills, and came up with this lovely thing. So as you go about your homework from today and your homework from Friday, you can go ahead and repeat the same process, except that if you're doing the homework from Friday, these numbers may just be c1 e to the 4t plus c2 e to the 7t or whatnot. So the same process holds for all of our solving. You may just have different numbers to start off with. If there's complex numbers in your roots, we know that we're going to have a sine and a cosine. Good luck, and I'll see you on Thursday.